It's 3:47 a.m. The nuclear football is open. Inside this briefcase are the authentication codes that can end civilization in less time than it takes to watch this video. The president has just been informed 43 intercontinental ballistic missiles have been launched from sites across Russia and China. 28 minutes until impact. The golden code is verified. The order is given. But here's the thing that should terrify you more than the missiles themselves. The United States has spent over $1.7 trillion on nuclear defense systems since the Cold War. And in the next 20 minutes, you're going to learn why none of it matters. Let me be clear from the start. This isn't fear-mongering. This isn't a conspiracy theory. This is the technical reality that military analysts, physicists, and defense strategists have been quietly acknowledging for decades. Because while you've been told that America has an impenetrable defense shield, the math tells a very different story. And today, we're going to walk through that math step by step so you understand exactly why the trillions spent on defense might not save a single city. The clock is ticking. Let's start with the arrow. An ICBM, intercontinental ballistic missile, is not just a rocket. It's a hypersonic delivery system designed to do one thing: carry nuclear warheads across continents faster than most people can finish their morning coffee. From the moment of launch, the missile goes through 3 distinct phases, and understanding these phases is critical to understanding why stopping them is nearly impossible. This is the boost phase. The ICBM's main engines fire for approximately 3 to 5 minutes, accelerating the missile to speeds of Mach 20 or higher. That's over 15,000 miles per hour. Within minutes, the missile breaks through the atmosphere and enters the edge of space. And this is where it gets interesting. Welcome to the mid-course phase. The missile is now in the vacuum of space, traveling in a ballistic arc, like a bullet fired from a gun. Except this bullet is moving at 17,000 miles per hour and is about to split into multiple pieces. Because modern ICBMs don't carry just one warhead. They carry MIRVs, multiple, independently targetable re-entry vehicles. One missile can carry between 10 to 15 individual nuclear warheads, each capable of hitting a different city. One missile becomes 10 targets, but it gets worse. Alongside the real warheads, the missile deploys decoys. These are lightweight balloon decoys coated with radar-reflective material. In space, where there's no air resistance, a 10-ton warhead and a 10-pound balloon move exactly the same way. To a radar system on the ground, they look identical. So now the defense system has a problem. You're looking at more than 100 objects moving toward your cities at Mach 23. Which ones are the bombs? Which ones are the balloons? You have 18 minutes to figure it out. This is the terminal phase. The warheads and the decoys re-enter the atmosphere at speeds exceeding Mach 20. The temperature on the nose cone reaches 3,000 degrees Celsius, hot enough to melt steel. At this point, the warheads are unstoppable by any kinetic defense system. They're too fast, too hot, too close. You have 15 seconds. Now let's talk about the shield that's supposed to stop this. Fort Greely, Alaska, one of the most remote military installations in the United States, and home to America's first line of defense against ICBMs. These are ground-based mid-course defense interceptors, 3-stage rockets designed to launch into space, locate an incoming warhead, and destroy it using a kinetic kill vehicle. Essentially, a guided bullet. Here's how it's supposed to work. Ground-based radar detects the launch. Systems track the missile's trajectory. The interceptor is launched. It blasts into space to intercept the warhead during its mid-course phase, while it's still outside the atmosphere. The kill vehicle uses infrared sensors to locate the warhead among the decoys. It homes in on the real target. Impact. If everything goes perfectly, the warhead is destroyed before it can re-enter the atmosphere. But here's the problem. This system is often described as hitting a bullet with a bullet, except it's worse than that. It's hitting a bullet with a bullet. when you don't know which bullet is real, and both bullets are moving at 5 miles per second. The United States has conducted fewer than 20 tests of this system since 2004. The success rate is approximately 55%. Let that sink in. In controlled conditions where we know the launch time, know the trajectory, and use a single warhead with no decoys, the system still fails almost half the time. Now imagine a real attack. 43 missiles, 400 warheads, 2,000 decoys, launched simultaneously from multiple locations, and the United States has exactly 44 interceptors deployed between Alaska and California. Do the math. Even if every single interceptor worked perfectly, we would run out of missiles before we ran out of targets. But it gets worse. There are other systems, THAAD and Aegis, but they're designed for regional threats, not full-scale ICBM attacks. THAAD can intercept short and medium-range missiles during their terminal phase. Aegis uses ship-launched interceptors to hit missiles in their mid-course phase. But their coverage is limited. They protect specific regions, not the entire country, and they're even less effective against MIRVs and decoys than the ground-based system. So when the attack begins, when 43 missiles split into 400 warheads, the decision isn't, how do we stop them all? It's, which cities do we try to save? 8 minutes until impact. Let's talk about what happens when one gets through. Let's say the target is New York City. Population, 8.3 million. The warhead is a W-88, the most common MIRV payload in US and Russian arsenals. Yield, 475 kilotons. That's 32 times more powerful than the bomb dropped on Hiroshima. It detonates 1,800 feet above Midtown Manhattan. Here's what happens next. A nuclear explosion begins with light. The detonation creates a fireball with a core temperature of 180 million degrees Fahrenheit. Hotter than the center of the sun. Within 1 second, the thermal pulse radiates outward at the speed of light. Anyone within 7 miles who has a direct line of sight to the blast is exposed to third-degree burns. Clothing ignites, skin vaporizes. Retinas are instantly destroyed by the intensity of the light, even if you're facing away from the blast. This is not an exaggeration. In Hiroshima, survivors reported shadows burned into concrete, the outlines of people who were vaporized so quickly. Their bodies shielded the ground behind them from the thermal pulse. 2 seconds after detonation, the shock wave arrives. This is an overpressure wave, a wall of compressed air moving outward at several hundred miles per hour. At ground zero, the pressure exceeds 20 pounds per square inch. That's enough force to collapse steel-reinforced concrete buildings. Everything within 2 miles of the blast is completely destroyed. 5 miles out, the pressure is still enough to collapse most residential buildings and turn glass fragments into shrapnel, traveling at over 100 miles per hour. Anyone caught in the open is shredded, but the explosion isn't over. The thermal pulse and shock wave ignite thousands of fires across the city, and those fires begin to merge. The intense heat causes hot air to rise so rapidly that it creates a vacuum at ground level. Cold air rushes in from all directions. Winds reach 100 miles per hour. Survivors trying to escape are pulled back toward the flames. Within 15 minutes, a firestorm forms. A firestorm is a self-sustaining inferno that creates its own wind system. It burns so hot that it consumes all available oxygen. People in underground shelters, even if they survive the blast, suffocate as the firestorm pulls oxygen out of the tunnels. The firestorm burns for days, but the deadliest phase is just beginning. When the warhead detonated, it vaporized everything within a quarter-mile radius. Buildings, vehicles, soil, people, all of that material was pulled into the mushroom cloud, irradiated by the nuclear reaction, and is now falling back to Earth as radioactive fallout. Within 24 hours, lethal radiation blankets areas hundreds of miles downwind. Anyone exposed to 300 roentgens of radiation will die within 2 weeks, even with medical treatment. In the immediate fallout zone, radiation levels exceed 5,000 roentgens per hour. Survivors don't realize they're being poisoned. The ash is odorless, tasteless, invisible, Within hours, symptoms begin: nausea, vomiting, diarrhea. Within days, hair loss, internal bleeding, immune system collapse. And there is no cure. Now remember, this was one warhead, one city. In a full-scale nuclear exchange, the United States would face more than 400 simultaneous detonations. High-altitude explosions would generate electromagnetic pulses, destroying the electrical grid. No power, no internet, no communication. The combined smoke from hundreds of firestorms would rise into the stratosphere, blocking sunlight. Global temperatures would drop by 20 degrees Fahrenheit. Crops would fail worldwide. Famine would kill billions in the months that follow, far more than the bombs themselves. So let's go back to the question we started with. Why can't the United States, the most powerful military on Earth, stop a nuclear attack? The answer is simple: physics. You can't intercept 400 hypersonic warheads traveling at Mach 23 with 44 interceptors that work 55% of the time. It's not a matter of money. It's not a matter of technology. It's mathematics. And the mathematics are unforgiving. This is why every president since Eisenhower has lived with the same terrifying knowledge. If the missiles launch, there is no winning. The defense systems we've built aren't designed to stop a nuclear war. They're designed to deter one. The doctrine is called mutually assured destruction, MAD, and it's kept the peace for 80 years. Not because we can defend ourselves, but because everyone loses if the missiles fly. So here's the uncomfortable truth. The only way to survive a nuclear war is not to start one. If this video scared you, good, it should. Because the alternative, pretending that we're safe, that the systems will work, that someone else will handle it, is far more dangerous than acknowledging the truth. If you want to keep learning about the systems, technologies, and policies that stand between us and catastrophe, subscribe and turn on notifications. Because understanding these systems, really understanding them, is the first step toward making sure we never have to use them. The clock is always ticking. Let's make sure